Today we discuss real numbers in 10th class. Now, first we have to discuss the introduction of the real number. In class 9, we already solved the rational numbers and irrational numbers. Now, we have to explore some more concepts on irrational number. How can we prove irrational number or fundamental theorem of arithmetic? By using these two principles, how can you prove irrational numbers? By using fundamental theorem of arithmetic. Now, what is fundamental theorem of arithmetic? What is fundamental theorem of arithmetic? This is states that every composite number can be written as the product of the prime numbers, and this factorization is unique apart from the order we taken. Suppose I take 5 into 3. In these both ways, 15 can be written as 3 into 5 or 5 into 3. Here 3 is a prime number and 5 is also a prime number. Here composite number 15 is a composite number. That means every composite number can be expressed as product of primes, and this factorization is unique apart from the order which the prime factors occurs. Here order is different. Here first we take 3, here first we take 5, but here the only prime factors involved in the 15 is 3 and 5. Here also 5 and 3, but order is different, but prime factors are same. This theorem is called fundamental theorem of arithmetic. Next, consider the number 4 power n. Here this is 4 power n. This is 4 power n, where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. We have to check whether either 4 power n is ends with digit 0 or yeah, 4 power n equals to 2 square whole power n, which is equals to 2 power 2n, which is equals to 2 power 2n. The only prime factor occurs in the prime factorization of 4 power n is 2. If any number can end with the digit 0, it must contain 2 and 5 in the prime factorization. But in the prime factorization of 4 power n, we have only 2, but not 5. So, by using the fundamental theorem of arithmetic, it cannot end with the digit 0. It cannot end with the digit 0. If any number end with the digit 0, if any number end with digit 0, the prime factorization of that number, must contain the prime factorization of that number must contain 2 and 5. 2 and 5. But the prime factorization of 4 power n, but the prime factorization of 4 power n contains only 2, but not 5. Only 2, but not 5. So, by using fundamental theorem of arithmetic, by using fundamental theorem of arithmetic, it does not end with digit 0. It does not end with digit 0. If any number end with digit 0, the prime factorization of that number must contain 2 and 5. But the prime factorization of 4 power n contains only 2, but not 5. So, by using fundamental theorem of arithmetic, it does not end with digit 0. This is the reason for why 4 power n cannot end with the digit 0. itself. Itself is the product of the smallest power of each common factor, each common prime factor in the number. But whereas LCM is the greatest power of each prime factor involved in the numbers. Here itself is the product of the smallest power in each prime factor in the numbers. But whereas the LCM is the product of the greatest power of each prime factor involved in the numbers. Now I have to discuss some examples related to LCM and HCF. Find the LCM and HCM of 6 and 20 by using the prime factorization method. Now, first the prime factorization of 6. The prime factorization of 6 is 2 into 3 and the prime factorization of 20. 2 into 5. The prime factorization of 20 is 2 into 2 into 5. That equals to 2 square into 5. Now, first LCM. LCM equals to the product of greatest power of each prime factor involved in the factorization. Here, 2, 3, 5. 3 prime factors are involved. Therefore, 2 into 3 into 5. The highest power of 2 is 2. And the highest power of 3 is 1. And also highest power of 5 is also 1. Therefore, 2 square 4 into 3 into 5. 4 3 is 12. 12 5 is 60. This is the LCM of 6 and 20. Now we have to find the HCF. HCF equals to product of least power of each prime factor involved in the factorization. Here the common prime factor is only 2. Therefore, the least power of 2 is 2 power 1. 2 is the HCF of 6 and 20. Therefore, HCF of 6, 20 is 2. And LCM is 60. Next one. Find the HCF of 96 and 404 by using prime factorization method. Hence, find the LCM. Therefore, first we have to do prime factorization for 96. 2 4 ja, 2 8 ja, 2 2 ja, 2 4 ja, 2 1 ja, 2 2 ja, 2 6 ja, 2 3 ja. And for 404, 2 2 ja, 2 1 0 1 ja. Therefore, 96 equal to 1 2 3 4 5. 2 power 5 into 3. And also 404 equals to 101 into 2 square. Now, first we have to find the HCF for 96 and 44. HCF for 96 and 404 is here. What is the definition for HCF? The product of the least prime factor involved in each of the factorization. Therefore, for 96 and 404, the common prime factor is 2. And the least power of 2 is 2. Therefore, the HCF of 96 and 404 is 4. Now, by using the definition, LCM into HCF equals to product of two numbers. Therefore, LCM of 96, 404 into HCF of 96, 404 equals to 96 into 404. This is by using the definition. By using the definition of LCM into HCF equals to product of two numbers. Now we have to find the LCM. We have HCF. HCF of two numbers is 4. Therefore, LCM of 96, 404 equals to 4 1 ja, 4 101 ja, which is equals to 9696. LCM of 96, 404 is 9696. Find the HCM and LCM of 6, 72 and 120 using the prime factorization method. Two 3s are 6. This is the prime factorization for 6. 2 36 ja, 2 18 ja, 2 9 3 3 2 60 2 30 2 15 3 5 Therefore, the prime factor for 6 is 2 into 3, and prime factor for 72 is 2 cube into 3 square, and also prime factor for 120 is 2 cube into 3 into 5. Now, LCM. LCM is the product of the greatest power of each prime factor involved in the prime factorization. Here, 2 and 3 and 5 are the only prime factors involved in the prime factorization of 6, 72 and 120. Therefore, the highest power of 2 is 3 and highest power of 3 is 2 and highest power of 5 is 1. Therefore, 2 cube 8 into 9 into 5. 8 5 are 40. Therefore, 360 is the LCM for these numbers. Now, I have to find HCF. HCF is the product of least prime factor in each of the three numbers. Here, 2 and 3 are the only common factors for 6, 72 and 120. Here, the least power for 2 is 1 and also least power for 3 is also 1. Therefore, HCF of 6, 72, 120 is 6. Therefore, express the each number as product of its prime factor. The first one is 140. We have to express 140 as product of prime factors. Therefore, the prime factorization for 140 is 2 into 70, 2 into 35, 5, 7. Therefore, 140 can be expressed as 2 into 2 into 5 into 7. Therefore, 2 into 2 can be expressed as written as 2 square into 5 into 7. This is the prime factorization for 140. Next 156. 2 7 2 8 2 3 2 9 3 1 3 3 Therefore, 156 can be expressed as 2 square into 3 into 13. This is the prime factorization for 156. The prime factorization for 156 is 2 square into 3 into 13. Therefore, 3825. 3 1 3 2 6 and remainder is 2 22 7 5 3 4 12 3 2 3 5 yes. 5 8 40 5 5 5 1 5 17. Therefore, the prime factorization of 3825 is 3 square into 5 square into 17. This is the prime factorization for 3825. 3 square into 5 square into 17. 15 years. 5005. 5 1 0 0 5 1 1001 is a prime number. Therefore, rather 3 7 7 wonders 7 3 0 7 1 7 3 0 30 7 4 28 2 1 7 3 Next 11 1 11 11 3 Therefore, 5005 can be expressed as 5 into 7 into 11 into 13. Therefore, the prime factorization for 5005 is 5 into 7 into 11 into 13. 7429. 7429. Here 17. 17 4 68. 62 reminder. 62 means 17 3s are 51, 11, 119, 17 7s are 119. Next, 19 2s are 38 and 19 3s are. Therefore, 7429 can be expressed as 17 into 19 into 23. 17 into 19 into 23. Next one. Find the LCM and HCF of the following pairs of integers and verify that LCM and HCF equals to product of two numbers. First, the prime factor for 26 is 2 into 13 and also 91 is 13 7 is 19 more. Therefore, 26 equals to 2 into 13. 91 equals to 7 into 13. Therefore, LCM equals to product of the highest power of each prime factor occurred in the prime factorization. Therefore, 2 into 7 into 13. 2 7 is 14. 14 into 13. 182. Next, HCF. HCF is the product of the least each prime factor. Therefore, 13 is the only common factor and the least power of 13. There 182 into 13. 13 2 is 26. 13 8 is 104. 106. 13 1 is 13 plus 10 23. 2366. And we have to multiply 26 and 91. 6 1 is 6. 6 9 is 54. 2 9 is 18. 6 6 2 366. Therefore, LHS equals to RHS. Therefore, LCM into HF equals to product of the two numbers. Now, 510 and 92. Prime factorization for 510. 3, 2 2 is 4. 2 5 is 2 5 is 3 8 is 3 5 is 5 1 is 5 7 is. For 92, 2 4 is 2 1 is. Yes or no? 6 are okay. 2 2 is 2 3 is. Therefore, 510 equals to 2 into 3 into 5 into 17. And also 92 equals to 2 into 2 into 23, which is equals to 2 square into 23. Now, LCM is product of each highest power of each prime factor. Therefore, here each prime factor 2 into 3 into 5 into 17. Here the highest power of 2 is 2 and highest power of 3 and 5 and 17 are 1. HF is here the only common factor is 2. Therefore, HF is 2. Therefore, HF is 2. 2 square 4, 4 3 is 12, 12 5 is 60, 17 6 is 1020 is the LCM. Now we have to check the relation between two numbers. 4 3 is 12, 12 5 is 60. 1020 into 23. 0, 3 2 is 6, 3 1 is 3. 0, 4, 0, 2. This is the LCM and this is the HCF. Now I have to verify the relation. LCM into HCF equals to product of two number. Here LCM is 23460 into HF is 2. 2 0s are 0, 2 6 are 12, 2 4s are 8 9, 2 3s are 6, 2 2s are 4. 590, 510 into 92. And here LCM and HCF equals to product of two numbers. Therefore, the relation is correct. Now, 2 1 the 2, 13, 2 6 the 2 8 the 2 8 the 2 4 the 2 4 the 2 2 the 2 2 the 2 1. Therefore, the prime factor for 336 is 2 power 4 into 21 and also 54. 2 2 are 2 7 are 3 9 are 3 3 are. Therefore, 54 is 2 into 3 cube. Now, LCM. LCM is product of highest power of each prime factor. Therefore, 2 power 4 into 3 cube into 21. 2 power 4 value is 16 into 27 into 21. 16 on the 16. 7 6 is 42. 7 3 is 21. 5 21 plus 4 25. 7 3 is 21 plus 2 23. 2 6 is 12. 2 3 is 6 7. 2 3 is 6. Therefore, 2 7. Therefore, 9072 is the LCM for 336 and 54 and HCF. Here, 2 is the only prime factor which is common for 336 and 54. The least power of 2 is 2 power 1. Therefore, HCF is 2. Therefore, now we have to find the relationship between LCM and HCF. We will do it. 9072 into 2. 2 2s are 4, 2 7s are 14, 2 9s are 18. Now we have to find the multiplication for 336 and 54. 4 6 are 24, 4 3 are 12, plus 2 14, 4 3 are 12, plus 1 13, 5 6 are 12, 5 3 are 15, plus 1 16, here also 16. 4, 6, 9, 27 into 21. 2 7, 2 7s are 14, 2 2s are 4, 5. 567 into 16. 16 7s are 1 1, 2, 16 6s are 96, 97, 107, 16 5s are 80, 90, 907. సరిపోయింది. 4 6 are 24, 4 3 are 12 plus 2 14, 4 3 are 12 plus 13, 5 6 are 30, 5 3 are 15 plus 3 18, 16, 4 4 1 8 1 4 4, 9072 into 2, 2 2s are 4, 14. Here LCM and HCF equals to product of two numbers. Find the LCM and HCF of the following integers by applying the prime factorization method. Therefore, prime factorization for 12 is 2 square into 3, 15 is 3 into 5 and 21 is 3 into 7. Therefore, LCM equals to product of the highest power of each prime factor. Highest power of 2 is 2 square and highest power of 3 is 1 and highest power of 5 is 1 and 7 is also 1. 2 square is 4, 4 3s are 12, 12 5s are 60, 6 7s are 42. Therefore, 420 is the LCM for 12, 15 and 21. And HCF is product of the least power of each common factor. Each common factor is only 3. Therefore, HCF is 3. HCF of 12, 15 and 21 is 3. LCM of 17, LCM of 17, 23 and 29 is 17 into 23 into 29, because these three are prime numbers. Therefore, LCM is equal to product of the numbers, and HCF is always 1. HCF is always 1. Now, prime factorization for 8 is 2 cube and 9 is 2 square, sorry, 3 square, 25 is 5 square. Therefore, LCM equals to 2 square into 3 square into 5 square. That means 8 9 is 72, 72 into 25. 4 1 is 1800. And HCF is 1, because there is no common factor for 8, 9 and 25. Therefore, HCF of 8, 9, 25 is 1. Here given that HCF of 306 and 657 is 9, we have to find the LCM for 306 and 657. Now we already know that the formula LCM and HCF equals to product of two numbers. Therefore, LCM is, we don't know, we have to find the LCM, and HCF is 9, which is equals to product of two numbers 306 into 657. Therefore, LCM equals to 306 into 657 by 9. 3 1 9 3 is 27, 9 36, 9 4 is. Therefore, 657 into 34. 4 7 is 28, 4 5 is 20, 22, 4 6 is 24 plus 2, 26, 3 7 is 21, 3 5 is 15 plus 2, 17, 3 6 is 18 plus 1, 19. 8, 3. Therefore, 22,338 is the LCM of 306 and 657. We already know that the LCM and HCF equals to product of two numbers. I used the same formula to solve this question. Therefore, I get LCM equals to 22,338. Check whether 6 power n can end with digit 0 or not. Tell 6 power n equals to 2 into 3 whole power n. Therefore, 2 power n into 3 power n. The prime factorization of 6 can contain 2 and 3. If any number end with digit 0, that must contain the prime factors 2 and 5. But the prime factorization of 6 can contain only 2 and 3. Therefore, by using fundamental theorem of arithmetic, it cannot end with digit 0. By using fundamental theorem of arithmetic, it cannot end with digit 0. Because if any number end with digit 0, it contains both 2 and 5 in the prime factorization of that number. But the prime factorization of 6 4 n only contains 2 and 3, but not 5. So, it does not end with digit 0 by using fundamental theorem of arithmetic. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 plus 5 into 4 into 3 into 1 plus 5 are composite numbers. Now, 7 into 11 into 13 plus 13. Now, we take 13 as common. 7 into 11 plus 1, that is 77 plus 1, 78. Therefore, this number can be written as product of two numbers. In these two numbers, so by using fundamental theorem of arithmetic, it is a composite number. Next. This also can be expressed as product of two numbers. Therefore, this is also not a prime number. This is a composite number. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same time. They can reach at how much time? Now I have to find the LCM and HCF for the 18 and 12. Therefore, 18 equals to 2 into 3 square and 12 equals to 2 square into 3. Therefore, LCM equals to 2 square into 3 square, 4 into 9. In 36 minutes, they will meet each other.